Okay, electronic configuration through element 54. Okay. All right, the next one is noble gas form. And what it is, it's basically a shorthand of this guy right here. What it is, so when you do like electronic configuration, so it's basically the electronic configuration for last row. And then you add something to take its place. I'll show you that. Okay, so I'll show you how it works, and then we'll just shorten it. Okay, so let's do chlorine. So chlorine is 1s2, 2s2, 2p6, 3s2, 3p6. Okay. It's right here, not 6, that's 3p5. So 3p5, so it's 1, 2, 3, 4, 5, and then 3s2, 2p6, 2s2, and 1s2. All right, the noble gas form is you write this guy down here, the last row. Okay, then let's take a look at this guy right here. What is this electronic configuration of? What thing has a 2p6? Neon, okay. So what we do is we just substitute this whole guy for neon. Okay, so what you do in a quick way is you write down the last row, and then you go up to the previous row's noble gas and write it down. All right. So that should be a 5. Okay, so let's do some of the ones we've done already. Iodine. Okay. If you look at, we just did it, but now so if you look at what'd you write? So what's the last row? So just write out where, so iodine's found in the 5th row, so you write everything that's found in the 5th row. So it's going to be 5p, 5, 40, 10, and 5s2. Okay, so you write everything that in this row you write down electronic configuration. Then you go one row up and you find its noble gas, and that's going to be krypton. And krypton has the noble gas form of 1s2, 2s2, 2p6, so forth, up through 4p6. All right. Okay, so that really shorthands it. Now, if you look at the periodic table, maybe even your own periodic table, you notice that's what they have. Okay. So if I look at iodine, it has Kr, 4d10, 5s2, 5p6. Okay. Same thing up there. So the periodic table has that information right there. Okay. And you notice some of them are different. Like I told you, like copper was not. So what is it for copper? Okay. So what is copper? Copper's was it's found in 4D, 9, 5s, 3d9, 4s2. And then one up is argon. Okay, what does the periodic table say? Ar 4s1 3d10. Okay, so if I ask you for when I ask you for on the test, I'm asking for the predicted one, not the real one. All right. Okay. And again, do that for 54. Okay, two more models. Okay, so the noble gas form gets rid of a lot of stuff as well. It gets rid of everything except for the last row. Okay, now what we're gonna do is we're gonna have what I call the Bohr model, but it's not really the Bohr model. Kind of looks like it. So I'm putting in quotations. So if you look up in your book and it says Bohr model, that's not the Bohr model. And the Bohr model basically cuts through everything, okay? What it does is it just gives you energy level and the valence electrons. That's it. So this guy is going to be energy level and valence electrons. And there's different ways to come up with that. We'll do it the hard way, and then we'll do it the easy way. So I'll start out with the orbital energy diagram. And we'll do oxygen. Then we'll do chlorine. Okay, so this is chlorine, and so this is the orbital energy diagram. I'm leaving the arrows off. That's electronic configuration, noble gas form. Okay. All right. The Bohr model is, you're just going to write down how many shells it has, and we'll get a diagram. Diagram how many shells it has and how many valence electrons. So how many shells does chlorine have?
3.
1, 2, 3. Okay. 1, 2, 3. So what you do is, okay. And then how many valence electrons does it have?
7.
Now, if you look at what is called the Bohr model, it puts electrons in the inner rings, and it pairs them up and all that stuff. I don't want to do that because it takes too long and it tells me the wrong stuff anyways. Okay. So we can figure this model out. So we can figure this out from any of these guys, but there's a real quick way to figure it out from the periodic table. Okay. So this is energy levels. Okay. Number of valence electrons is what row it's in. All right. Oh, so here's something. Okay. How many valence electrons does magnesium have? How many? 2. How many valence electrons did oxygen have? 6. How many did chlorine have? 7. How much did argon have? 8. Okay. So the periodic table gives you a hint how to figure that out with doing all this stuff. If you look at the Roman numeral A, that'll tell you how many valence electrons it has. So first column has 1A. How many valence electrons does sodium have? 1. All right, you just told me magnesium has 2 valence electrons. What is it? 2A. Oxygen has how many valence electrons? 6. And what is it? 6A. If you can't read your Roman numerals, that's fine. Probably in your book, I think they use regular numbers. So it's Arabic numbers. So, and fluorine is 7, and argon was 8. Okay, so you don't need to know all this stuff. You do need to know it, okay? But we can shortcut everything by just doing this. Roman numeral. Okay, now if you look in the middle, you have B's, okay? So how many valence electrons do they have? Well, they have the same as this guy right here. So all of these are 2A's. All right, so all of these, so it's 1A, 2A, all the way 2A, and then 3A. Okay, so all those guys in the middle, these guys too, these all have 2 electrons in them too, using our method. All right, so what we can do here is that we can do the Bohr model. We can figure out the Bohr model from this guy, this guy, and this guy, or just really quick it from the periodic table. You can figure out the Bohr model for every single element on the periodic table. So let's do one that, let's do, no, let's do us. Let's do us. That's the couples element. Us. So UUS right here. What is the, so do the Bohr model of UUS. Should be a TV show. So what row it is, and then look at the Roman numeral A. Okay, so that's it. All right. Last model. Okay, the last model is Lewis dot, and Lewis dot gets rid of everything except valence electrons and the element. Okay. So the only thing you have to know is the element and how many valence electrons. But there's a little trick to it, and that's how you're going to demonstrate or demonstrate those valence electrons. Okay. All right, so you can use any one of these models to figure out the valence electrons. Okay, it's the orbital energy diagram. You draw, put all the arrows in the last row, count the arrows, and that's how many valence electrons. Electronic configuration, you just write them all down, and whatever the highest number is kind of your valence electrons. Noble gas, same thing. Bohr model, you figure it out from all the other ones on the periodic table. Lewis dot structure. So what you need is a valence electron. So you get them from all these other models, but we're going to go straight to periodic table. Okay, so I'm going to do a few. There's only 8 possibilities. Well, actually not. But this could be 10. No, 9. And we'll go through them all. Let's start out with oxygen. Okay. so oxygen has 8 valence electrons. Well, so does everything else, and not 8. Does it? It has 6 valence electrons, okay. So everything in the column also has 6. So the Lewis dot structure of oxygen is the same for all of these guys, except what you do is you replace the O with whatever element you have. Okay, so what you do is you write O, and then what I do is I'm going to put a box, then you get rid of the box, but at least that gives you an idea. All right, before we do that, remember when we were putting electrons in a p subshell, the way that you did is you went up, up, up. So you put an electron in each box before you came back and filled up, paired. Okay, we're going to do the same thing here, is we're going to put a dot to represent an electron on a side, but we can't pair them until we have a dot on each side. Okay, so oxygen has 6, so I'm going to put 1 here. It doesn't matter how you do it. I remember when I taught it, and I've heard people, and when I learned it, you go clockwise, and then you start from the top and go clockwise. It really doesn't matter. You can start anywhere you want, as long as the first 4, if there is 4, you get on the side. Okay? And then you got 2 more. Well, you put them anywhere you want. As long you can't have any more than 2 on the side, just like the orbitals. So you do that. All right. So sulfur would have an S here instead. Selenium would have an Se and so forth. Okay. Let's do nitrogen. Nitrogen has 5. Okay, so you put 1 on each side. You have 5. Okay, and then you put the other one on any side you want.